Hello everyone, welcome to Sam's Science View channel. In today's video, we are going to listen to science behind football. In specific, we are going to discuss about free kick. Before going into the video, please watch this entire video and do subscribe to my channel and watch my entire video and give comments about it. Now let's get into the video. The likes of Lionel Messi and Cristiano Ronaldo are known around the world for their expertise in the art of the free kick. Whether it's a curler into the top corner or a thundering pile driver, free kick taking is a vital part of the modern game. But how does science come into scoring a goal? There are basically three broad techniques to score through a penalty kick. Your first strategy could be to go with a brute force and just try to force the ball in directly with a powerful kick. If you're savvy, you could use some technique to curl the ball around any obstacles using the inside or outside of your foot. And if you really have some skills, you can spin that ball and make it zoom through the air unpredictably. It's that last method that's especially interesting. At this point, it's worth providing a quick primer on the physics of soccer. Don't worry, this won't be complicated. The first part has to do with Newton's law of inertia, which states that any object at rest stays at rest and any object in motion stays in motion unless another force acts upon it. When it comes to a free kick, the force that makes the ball move up and accelerate is a player's foot, and the forces slowing the ball down as it moves through the air include drag and friction caused by wind and gravity. Next up, the concept of momentum, which we might have memorized as velocity of an object times its mass. A player's foot moving through the air can transfer momentum from itself to the ball it strikes. Making a ball move faster or higher through air requires more momentum. So a player needs to hit the ball with more force. If you're trying to curl the ball up or to put a spin on it or both, you need not to only exert more force but also balance that with your willy foot technique. Tricky stuff. The guiding principle is the Magnus effect, investigated by German physicist Heinrich Gustav Magnus. This law of physics demonstrates that airflow is distorted around any spinning cylinder or sphere in a certain way. That basic understanding of physics brings us to the big Tamil, this Magnus effect, which explains how a player is able to bend a ball into the goalpost during a free kick. When a soccer ball moves through the air, it's the air that begins to take charge and moves, or in this case, curves the ball to its own liking. To start, the kicker needs to put a spin on the ball as he strikes it. Basically, the top spin of the ball causes air around the top to move less than the air around the bottom half. The tangential velocity of the ball in the top half is opposite the airflow, and the tangential velocity of the bottom half is in the same direction of the airflow. This imbalance means the pressure on the ball is greater at the top. The Magnus effect becomes more prominent and noticeable as the ball loses velocity because at some point the airflow that is moving against the spin is halted. The pressure imbalance is heightened and creates a force on the ball that acts both downward and against the side of the ball that used to create an opposing airflow. When a soccer player's kick creates a counterclockwise spin, the Magnus effect acts left on the ball, causing the ball to curve left and vice versa. Because the Magnus effect increases as the velocity decreases, you notice the curve in the ball happening much more rapidly as the ball begins to make its way back down towards the ground. The curve on the ball gets harder and harder during flight, fooling the goalkeeper and other nearby defensive players from correctly tracking it as it moves down. If you apply just the right amount of force that ensures the ball will make its way downward into the net in time, you will produce a free kick that seems to have a life and mind on its own. If the ball is spinning counterclockwise, that is anti clockwise, the left side of the ball will experience less drag as it moves in the same direction as the airflow, while the right side spins against the onrushing air, increasing the drag. This creates a pressure imbalance with the right side of the ball experiencing high pressure and the left side experiencing low pressure. It is this imbalance which forces the ball to move to the area with low pressure, thus curling to the left. You can see this Magnus effect in Brazilian player Roberto Carlos' 1997 free kick against France. But the Cristiano Ronaldo style of free kicks, like knuckleball kicks, is a whole different ball game. The idea behind the immensely powerful swerving free kick is imparting as little spin as possible. As the air flows over the ball, a boundary layer is produced, which is a cushion of air that sticks very tightly to the surface of the ball. If an imperfection in the ball disrupts this airflow, it will deviate in the air. A rapidly spinning football won't deviate much, but a ball hit flatly will, as it will have more time to move in the direction of the disruption. So, when Ronaldo strikes the ball with little spin, any minor imperfection in the football will cause it to move during flight and outfox many a poor, bewildered goalkeeper. It's not easy to master something like this, but the result can be devastatingly gorgeous and ridiculously physics defying during a free kick. That's it for today's video. Hope so you got some physics based ideas behind this free kick in football. Do subscribe to my channel and like, share and comment about my video. Do watch the oncoming videos, sports related, and which is science behind these sports videos on oncoming days. Do comment about it. Let's meet in the next video. Until then, take care and goodbye from Sam.